Good. So today we'll review for our exam. You have your exam available today at 1 p.m. It's already set up, waiting for the time to be 1 p.m. so you can start downloading it and working on it. Okay. So we reviewed anyways chapter 13 last time, and we're going to do chapter 14. You can also ask questions from chapter 13 if you still have any. But I'm going to start working on some of the problems from chapter 14 from our sample final exam. And for reference, next week, we're also going to be reviewing. So we're going to be looking at um, the entire week, the entire material for the semester in preparation for our final exam. Okay. Let me go to the review sheet of problems right there. You have them on the screen. So the ones that correspond to chapter 14 start right here on 33. So if you have a specific one that you would like to see, please let me know, either voice or write on the chat area, okay? So let's see, starting with 33, we have find the equation for the line segment, find the equation for the line parallel to another line, or the equation to a line perpendicular to another line. So let's try those. First, a line segment. How do we do line segment? So you have to use the 2 points that you have. So for 33, 33A, we have the points 1, 2, 3, and 3, 1, 6. So let's make a picture, and I'll tell you one way you can do them. There's several ways. So 1, 2, 3, and 3, 2, 6. Let's do a picture right here. So these are missing another set of axes. My bad. Let's try again. So the X, the Y, and the Z. Now we have 1, 2, 3. So that's 1 in this direction, 2 in this direction, and then 3 in this direction. 3 units high. And this is this 1, 2, 3, and the other is 3, 1, 6. 1, 3, 1, and 6 units high. Right here. That's 3, 1, 6. Okay. So the idea is, let's give them names. Let's say that this is A and this is B. So this is A, and this is B. So the idea is that you use the vector, right? Which vector do you like? You could use either A to B or B to A. It doesn't matter. And that this is the easiest way of doing it. So you can do B to A, for example. And if you do B to A, then to parameterize the line segment, you start at B. So you start at the point B. So it's the origin. So you do OB. So from the origin to B, and then you add the vector BA times some T. And when T is 0, you're gonna be at B. And when T is 1, you're gonna be at OB plus BA, which is OA. So 0, T between 0 and 1. That's the easiest way of doing it. And it will always be between 0 and 1 if you use the entire vector BA. Okay? So you could also do, so this way you go from B to A. If you want to start at A and go to B, then instead of using the vector, oh, I wrote it wrong. This should be BA. If you want to go from A to B, then you have to use the vector AB. Okay? So this is it. So you just gonna have to write it. What is the vector OB? The vector OB is 3, 1, 6. And what is the vector BA? Remember, it's always the head minus tail. So it will be 1 minus 3, 2 minus 1, and 3 minus 6. And that's it. That's the this is the equation of, so this is your R of T. This is your vector equation between 0 and 1. It parameterizes the line segment. If you want the entire line, then don't do between 0 and 1. Do negative infinity, less than t, less than infinity. So for the entire line, use negative infinity, less than t, less than infinity. All right? That's the easiest way to do it. Let's go back to the problems. So let's look at these other ones. So for these other ones, say, find the equation of a line parallel to another line. Okay, so if you want it parallel to another line, it means it has to have the same direction. So for that, the only thing you need to use is the direction of this second line. Figure out what is the direction vector of that second line. And similarly, for part C, it says find the equation of a line perpendicular to another line and to the y-axis. So for that one, you need to first find out the direction that is perpendicular to the other line and to the y-axis. And to find something that is perpendicular to two other things, you can use the cross product. That's the way to do it. All right, parallel means the same direction. Perpendicular to two other ones means you should use the cross product. All right, so that's how we these parts B and C are done. Let's pick one of them. Probably C is the harder one, or at least let's outline both of them. So let's outline part B. So we want, for part B, it will be line through 3, negative 1, 1, parallel to the line RT, which is given by 7 plus TI plus 2TJ plus 2 minus TK. Okay, let's go to the page. Okay, so the first thing you want to do is figure out what's the direction from here. So separate these. So let me write it with components. To me, it's easy. So this is 7 plus t, 2t, 2 minus t. And then separate the constants. So this would be 7, 0, 2 plus t, 2t, negative t. Right? You see what I did here? I separated the constants. The constants were 7, 0, and 2. And that's just like a point there. So these we don't care about. We only care about this one. That's the direction. So this is 702 plus t. If you extract the t, 1, 2, negative 1. All right, that's great. This is the direction vector. This is the direction of the line. Direction of the line. So we're good. So to finish the problem, we only need to do a line that goes through this point with this direction. Well, that's easy. So here's the answer. The answer, I cannot call it R because the name R was already chosen there. So let's call it S. So S of T will be start at this point and then use this direction between negative infinity and infinity. That's it. Easy peasy, right? So like I was telling you, you only had, the only hard part was to find the direction of this line over here. And you do that by extracting the constants and figuring out what is what are the coefficients of the t. All right, now let's take a look at part C. So for part C, we want a line through 1, negative 1, 2, perpendicular to R of t equals 2 plus 3t, 1 plus 2t, negative 3 plus 5t, and the y-axis. So we need to find the direction of this line again. And now we learn how to do it. We can bypass a few steps. So this is just 2, 1, negative 3 plus t times 3, 2, 5. And this is the direction, right? This is the one I care about. So I gotta be perpendicular to 3, 2, 5, and also perpendicular to the y-axis. So what is the direction of the y-axis? So direction of the y-axis. Well, there's tons, but the easiest way is to use 0, 1, 0, right? You could put any number here. It could be 0, 24, 0, or 0, 7, 0, whatever number, but I like 1. 1 is the easiest, right? Because there's nothing in the x, nothing in the z, only in the y. That's the y-axis. Had we had the x-axis instead, it would be 1, 0, 0. If you wanted the z-axis, it would be 0, 0, 1. Is that clear? So now we want perpendicular to these two. And to find perpendicular to these two, we do the cross product. So to find a vector perpendicular to both 0, 1, 0 and 3, 2, 5, we do the cross product. Okay, so let's do it. We have to do 3, 2, 5 cross product 0, 1, 0. Order is not important, right? Either way, you're gonna get a correct direction vector. Maybe you get this one, or maybe you get the one in the opposite direction, but either one of the two works, okay? So this is what? This is ijk 3, 2, 5, 0, 1, 0, which is I times 3, 5, 0, 0, minus j times 3, 5, 0, 0, plus k times 3, 2, 0, 1. This is not right. There's something wrong here. When it should be 2, 5, 1, 0. Yes, so when you do you cover this one. So you get this. When you do j, you cover the middle one. That's fine. And when you do k, you cover the last one. So this is I times 0 minus 5 minus j, 0 minus 0, plus k times 3 minus 0. So this is negative 5i, no j, and 3k. So this is negative 5, 0, 3. And like I was telling you always, you can check if you're correct or not by doing the cross product. The dot product, I mean. The dot product should be 0. The dot product of these two is easy. It's 0 times this is 0. 1 times 0, 0. 0 times 3, 0. So it's 0. Perfect. Now this with that, it would be 3 times negative 5. That's negative 15. This is 0. That doesn't count. And then 5 and 3. That's positive 15. Negative 15 and positive 15. 0. We did good. Fantastic. So this is the direction we should take. So then now we can go back to the problem. The problem was get a line through this point and with this direction. So the answer is S of t will be start at the point you want, 1, negative 1, 2, and then put t with the direction that you want. With t between negative infinity and infinity. All right? Questions so far? Very good. So that's problem 33. And so here's a few other ones. So now let's take a look at them. So for 34, we have finding the unit tangent vector. How do you find the unit tangent vector? To get the tangent vector, you get, that's the derivative, right? The derivative, we know it's tangent to the motion. Remember all those graphs that I showed you where I had the red arrow? It indicated how fast you were going and in which direction. And to make it unit, you divide by its magnitude, right? So that one is easy peasy. We can check it in a moment. To find the unit tangent vector at a specific t, you just plug the t. And to find the tangent line, you have the direction. You just add the point plus the direction, right? So let's take a look at 34a. It's really the only one that's a little bit challenging there. So we have r of t is ln of 2 plus t, 2t, t squared. What is the derivative? Derivative of ln of something is 1 over something times the derivative of this, which is 1. The derivative of 2t, 2. The derivative of t squared, 2t. So that's the derivative. And then to find the unit tangent vector, all you need to do is do the derivative that we just did divided by the magnitude of the derivative. So this is this vector divided by the magnitude of this same vector, which is this 1 squared plus 2 squared plus 2t squared. And that's it. You could leave it like this, or if you want, you can write it, you know, like this first one divided by all of these. Comma 2 divided by da da da, 2t divided by da da da, the square root of all of that. Okay, either way, you can leave it here. This is fine. Okay, but the way you multiply by a constant is you multiply each one of the components. So that's the answer. And then if you want to find that, so for part B is what is this? What is the unit tangent vector at -1? What is the unit tangent vector at t equals -1? Well, to do that one, just plug -1 in here. And that's going to be -1 plus 2 is 1. So that's 1, 2, -2 divided by the magnitude of this one, which I can do now. It's easy. It's 1 squared, 2 squared, -2 squared. That's 9. So that's 3. So that's 1/3, 2/3, -2/3. Okay? Easy. Really straightforward. Not a lot of thinking or difficulty there. So let's continue. Then we have these problems, 35 and 36. 35, we have a specific acceleration and with some initial velocity and initial position, and then a bunch of questions. So let's go over that one. So we need to find the velocity and the speed and the position. Okay, so let me write down what's the acceleration. The acceleration will be cosine t times I minus plus sine of t times j plus 6t times k. And this is in meters per second squared. And move myself so I can see what's behind. Suppose it has an initial velocity v0 of 2k. This is in meters per second. And initial position initial position 2I minus km meters. These are meters. So these are meters. Okay, so find the velocity is part A. Find velocity at time t. Find the speed is part B. And part part C is find the position of the hummingbird at time t. And does it, this is kind of weird. And I don't know what this is, this thing and at the end. I think it was maybe the solution, maybe a typo, where the solution is right there. This thing kind of looks like the solution. This part over here, I don't know what that is. Maybe it's the solution. I don't think that should be there. It's maybe a typo, but never mind that. We'll do it. So here it is. Good. So how do we go from acceleration to velocity, right? And you need to remember that the acceleration is the derivative of the velocity. So to get the velocity, you do the antiderivative, right? Yes, Juanita, I knew you couldn't see my paper, but I was copying from the screen, so I couldn't show you my paper because then I couldn't see the screen. All right, sorry for that. The velocity, so to get the velocity, we need to integrate the acceleration, right? So what is the acceleration? We have it right here. I'm gonna write it in vector form. It's cosine sine 60. So here we go. Will be the integral of cosine, the integral of sine, and the integral of 60. Well, we integrate piece by piece. The integral of cosine is sine plus some constant. The integral of sine is negative cosine plus some other constant. And the integral of 60 will be 60 squared over 2, so 3t squared plus some constant c3. Right? So that's it. That's our velocity. Now, to get the constant, you use the initial condition. What is v of 0? So v of 0, on the one hand, we were told is 2k. So 2k is the same as 0, 0, 2. And on the other hand, this should be negative sine of 0, which is 0, so c1. Cosine of 0, which is 1, negative 1 plus c2. And 3 times 0 squared, which is 0. So that's c3. And from here, you get that c1 is 0. c2 minus 1 is 0. So that means c2 is 1. And c3 is 2. So c1 is 0, c2 is 1, and c3 is 2. So here's the velocity. The velocity will be right here, sine t plus c1, that's nothing, minus cosine t plus c2 plus 1, and 3t squared plus 2. Voila, that's our velocity, all right? And then last question says, find the position of the hummingbird. So for the position, we know that the derivative of the position, so we know that v of t is r prime of t. So to get the position, we integrate the velocity. So it's like do this again, right? So we need to integrate sine negative cosine plus 1 and 3t squared plus 2. And this is the integral of sine, that's negative cosine. The integral of negative cosine, that's negative sine plus t. And the integral of 3t squared, that's t cubed plus 2t. Notice that I didn't put the constant, so this time I'm going to put plus a constant vector. You can do it like that, so I'm showing you different ways. In the previous one, I put the individual constants, constant 1, constant 2, constant 3. You can do that way, or you cannot put the constants and then just put a constant vector. And that works too, all right? So then to find out the constant vector, you use the initial position. For here, the initial position is right here, 2i minus k. So that's the same as 2, 0, negative 1. So let's use that. So 2, 0, -1 is the position at 0, which is the same as when t is 0, that's -1. Sine of 0 is 0. T is 0, so that's 0. 0, 0, that's 0, plus c. And then you can solve for c as a vector, right? So the vector c is 2, 0, -1 minus -1, 0, 0. And you do this component by component. So 2 minus -1, that's 3. 0 minus 0 is 0. And -1 minus 0 is -1. So that's it. You get the vector c. Then you can put it together in here. So here's the answer. And R of t will be negative cosine t plus 3, negative sine t plus t, and t cubed plus 2t minus 1. Okay? I'm curious. I want to check if that's the same thing that they had later. Yeah, that's the answer to the problem. I don't know what it's doing right here, but that's the answer, right? Okay, good. What else? We have one more problem, and this is about arc length. Find the arc length of these parametric curves. And again, you only need to remember, so the thing with this is the integral may be difficult, but setting it up should be straightforward, right? So for arc length, we know that, so let me pick one of these. I think they all look easy because I think things will cancel. So let's take a look at the first one. The second one, you're gonna get sine squared plus cosine squared equals 1, and things will cancel. So that I think the second one is easier. So let's do the first. So the first R of t is e to the 2t plus 1, 2e to the 2t minus 1, and 2e to the 2t from 0 to ln 5. Let's do it. So what is the length of this curve? So the length is an integral from 0 to ln 5 of the absolute value, the magnitude of the velocity, so r prime. So it's the speed, in other words, this is the speed. So if you integrate the speed, you get the length of the curve. Okay, so you just need to do that. What is what is r prime? R prime is the derivative of this, that's 2e to the 2t. The derivative of this, that's 4e to the 2t, and the derivative of this, which is 4e to the 2t. Then how do we get the magnitude of that? Well, that's the square root of this one squared. So that's 4e to the 4t plus this one squared, that's 16e to the 4t, plus this one squared, and that's another 16e to the 4t. So altogether, this is 36 e to the 4t, which we can now simplify. The square root of 36 is 6, and the square root of e to the 4t is e to the 2t. I don't need absolute value because e is always positive. And now I only need to integrate this. So antiderivative of 6e to the 2t, and that's easier, right? Because it will be simply 3e to the 2t from 0 to ln 5. So this is 3e to the 2 times ln 5 minus 3e to the 0. And you could leave it like that, or you can realize that this is the same as e to the ln5 is 5, so this is 5 squared. So this is 75 minus 3. But it's perfectly reasonable and correct to leave it right here. Okay. So this actually was not that bad, right? Sometimes because the square root canceled, right? That's why we didn't have any problem. The square root canceled here. So sometimes what you need to do is try to complete the square inside so that you can take the square root, right? That's the number one hint. If you have a square root of something, you try to complete the square so that you can continue with the integral. All right. I think that's it. We don't have any more problems here. So we have arc length. We have, motion in 3 space. The derivative of the position is the velocity, and the derivative of the velocity is the acceleration. That's essentially what you need to know. And we have parametrizations of lines and line segments, and so on. I mean, this was chapter 13. Before we did cross product and dot product. Okay. So any other questions you guys may have? Okay. If there aren't any, we can stop earlier for today. You don't have any other problems that you may want to have questions on, and that's fine. Well, and like I was saying, we're gonna continue reviewing the entire next week in preparation for our final exam. And as soon as I know the indications for the instructions for the final exam, I'll let you know. I believe it will still be, so we will have a similar format. And it may even be longer time. Instead of 24 hours, it may even be longer. I'm not sure about that. It depends on whatever the coordinator lets us know. Can you go back to 34B? Well, yes, we can. I'll put it in a moment. And Nancy asked, do you still have the same office hours as on the syllabus? Yes. So there's a link on our, I think I put it on the announcement, another code for my office hours. So yes, same office hours. Mondays, Wednesdays, from 9:30 to 10:30. And can you back to 34B? What was 34B? Let me see. So 34B was the unit tangent vector at -1. So it's right here. I'll put it on the screen. Right here. So we first calculated the derivative, and then the unit vector is simply the derivative divided by its magnitude. So right here for 34B, I simply plugged -1 in here. So we wanted it at -1, so plug -1 here. 2 minus 1 is 1. That's a 2. And then 2 times -1, that's -2. And then you're going to divide that by the magnitude of this vector. So that's 1 squared, 2 squared, -2 squared, which is, oh, this is not right. Or is it? No, it is right. It's 1, 4, and 4. So altogether is 9. The square root of 9 is 3, so I put them in here. So you can stop right here as well, okay? This is correct. If you finish the problem right here, technically correct. Okay. Very well. So I wish everyone good luck with your exam. I'm hoping you guys will do fine. Can you back to the last problem? Sure. Okay. Go back to the last problem. Just put it on the screen, and I keep talking to you. This is the one we did. We did the arc length of this expression the way you do it is you do the derivative first, and then the square, the magnitude of the derivative. And that's what we did. We first found the derivative vector, so the derivative of each one of these is right here. And then to do the magnitude, you square them, right? And be careful with the rules of the exponents. When you square e to the 2t, is you e to the 2t to the second power, so the exponents multiply themselves. So it's 2t times 2. That's why you get 4t over here. Same thing here, 4t and 4t. And then we were lucky that these are all the same kind of things. So you could add them up and then simplify and get rid of the square root. Good. So also let me remind you, we have all the, except for last session that I couldn't save, I couldn't record. All the others are on YouTube. You can take a look at them, and I usually edit them. I mean, remove the unnecessary pauses and add little notes in case there were little problems here and there. So if you are fishy about anything, if you want to review a particular theme that you don't exactly remember, you can always go back and watch the videos, right? A great resource for you guys. Okay, very good. So I'll see you guys next week. Good luck with your exam and stay safe.